to chapter 3, and you're probably wondering, well, why? One of the things is first semester, I like to cover all the trig stuff first, especially for the December ACT test, which some of you take. And so we're done with the trig stuff. Now what we're going to do is get into a lot of the pre-calculus concepts. And so that's why we're back in chapter 3. Like I said, you'll notice we'll skip around. We'll jump up to, I think, chapter 7 and 8 next. Okay, and so anyway, you'll just make sure you need to follow along. And we're going to define what a transcendental function is. Okay? A transcendental function is a function that cannot be expressed in terms of algebraic operations. So basically, like x plus 4, 3x squared minus 2x plus 5. Those would not be transcendental functions. So when we think about transcendental functions, we think about the exponential or the logarithmic functions. And that's what we're going to focus on in this chapter. Okay, we're going to focus on the exponential and the logarithmic functions. And these are functions that are used a lot, especially in science. And we're going to talk about that a little bit today. Okay, now what we're going to do today, just for sake of time, is we're going to actually split up today. Tomorrow we'll do some of the graphing with this section, but today we'll focus strictly on kind of some of the word problems. And so first of all, what we're going to do is we're going to define what an exponential function is. Okay, and on this next slide, an exponential function with base b is defined as y equals a times b to the x. Now I'm going to let you get that down, and then we'll talk about the line below that and what it all means. So exponential function with base b, y equals a times b to the x. Now it says a cannot equal 0. Now I want you to think, why couldn't a equal 0 here? Yeah, because then the whole function would equal 0, and we wouldn't have a function, it would just be y equals 0. So a can't be 0, it can be anything other than 0. It could be 1, 2, 3. Okay? B is greater than 0 means B is what type of numbers? What type of numbers are bigger than 0? What? Real number. Okay. Just in general, what types of numbers are bigger than 0? Counting numbers. Okay.
1.
You're thinking, I think, way too difficult. Okay, on a number line, we have 0, right?
Positive.
Positive numbers there. So basically, B is positive. That's what they're saying right here. Okay, when it says greater than 0, it's a positive number. B cannot equal 1. Why can't it equal 1? The function would just be 1, right? Yeah. So the function would just be 1. And then x is an element of the real numbers. That's what that is. That's an R. That stands for real numbers. So let's review what a real number is. A real number is a what?
I don't know, anything that's not real.
Okay? A real number is basically just any number. Okay? That's what a real number is. It can be positive, it can be negative, fractions, decimals, whole numbers. Okay? So with that in mind, with what I've given, with that in mind, I want you to look at that, and I want you to tell me, is y equals 4 to the x, oh, a second. We'll try that one again. Evidently I clicked twice. Okay, there you go. Is f of x equals 4 to the x an exponential function? Yes or no? If you don't know, I just want you to take a guess. But I want you to think back to what we talked about with exponential functions. And it is yes. Good job. Okay, what is a in this problem? 1, right? There's not really an a written, so it's just implied to be 1. So 1 times 4 to the x. With that in mind, is that an exponential function? Yes or why is it doing that? We'll try it again. Is f of x equals 7 to the negative x an exponential function? Yes or no? Oh, okay, we got about half and half. Okay, so what I want you do, those of you that answered no, I want you to tell me, why did you answer no? Because it's negative. Now I want you to think back. This is negative, right? It said x had to be what? A real number. Is a negative number a real number?
Yeah.
Yeah. So is this an exponential function? The answer is yes. Okay, so you can have that negative exponent. Okay, is f of x equal 1 to the x an exponential function? No. Why is it no? Because b cannot equal 1. That is exactly right. Remember, b could not equal 1. That was on that. What about this one? Oops, sorry. Is f of x equals 1/3 to the x an exponential function?
Alright.
Oh, had a lot of no's. For those of you that answered no, why did you answer no? Because there was a fraction. Now I want you to think back to what it said b could be. It said b had to be what?
Not 1.
Greater than 0, and b can't be 1. Is 1/3 greater than 0? Yeah, so you can have a fraction. Okay. So, with that in mind, we're going to look at this, and we're going to spend a little bit more time tomorrow talking about the graphs. What I want you to understand today is that with exponential functions, you can have both exponential growth and exponential decay. Okay, exponential growth means something grows, gets larger, gets bigger. So an example of something that would be something that grows exponentially might be like a disease. Might be like how the flu spreads. Bacteria, how bacteria grow and multiply. Okay, exponential decay is something that gets smaller, so that would be like the half-lives, if you've ever heard that in science. Okay, when they talk about half-lives of an element, okay, that's exponential decay. Okay, a little bit about the growth function. B has to be bigger than 1. So B would have to be like 1.1 and bigger, 1.01 and bigger. For the decay, B has to be between 0 and 1. So decay is basically like the fractions, like that 1/3 we had in the problem before, or that 1/2. Okay. And we'll talk, like I said, more about that tomorrow. We'll actually graph those tomorrow as well. Today we're going to finish out with, interest. Okay, and this is where we're going to finish out today. We're going to talk about compound interest, both a specified time interval and continuously. So this is a formula you've seen before. This should be nothing new. Okay. And so I'm going to let you get that down. P is your principal, which is your starting amount. Okay, that's what you start with. R is your rate as a decimal. You always put this as a decimal and get rid of the percent sign. So an example would be that like 3% is actually 0.03. N is the number of times compounded per year. So if something's compounded quarterly, which is what you see it happen a lot, that would be 4 times a year. Okay. One of the things about this is when you're talking about daily, there is some school of thought that actually has used 360, and that is in some business books that I've seen. For sake of being consistent, I want you to use 365 for daily. And then T is your time in years. It is always in years for time. Okay. Oops. Okay, so after you get that down, I'm going to go ahead and go to the next slide, which will be a problem. And this says if you invest $8,000 at 4% compounded quarterly, how much do you have after 6 years? Now, believe it or not, when I was in high school, in my savings account, I was earning 3% interest.
A lot.
Well, right now you're lucky to get 0.5%. So it was actually paying quite a bit more back then. So then right now it says if you invest $8,000, so here's my formula, A equals, my principal is $8,000, that's what I start with. Okay? Then I write a 1 plus, what is my rate as a decimal? 0.04. What is the number of times compounded per year? 4. And then I've got to the n times, what's my t? Time. 6. Now I'm going to tell you one thing that you will always do, okay? You will always, at the very end, multiply by 8,000. You need to focus on this first. That 8,000 you don't mess with till the very end. Okay, so make sure you understand that. Leave that 8,000 alone. So now what I'm going to do is I'm going to focus on the parentheses. And the parentheses in this case say 1 plus 0.04 divided by 4. So I'm going to go ahead and calculate this. 0.04 divided by 4. So go ahead and do that for me. And what do you get? 0.01. I want you to add that to 1. Okay? And so if I add that to 1, I get 1.01 to the 24th power. So now what I want you to do is go ahead and calculate for me 1.01 to the 24th power. Okay, now you should have gotten a number like 1.26, 1.27. I want you to leave that number, so don't round up or anything. And so after you've calculated this, I want you to hit the times sign. So just hit the times sign and then type in 8,000. And when you do that, you should get your answer, which is 10,000. Yep. 88 cents. Okay.
So you take 8,000
I would do the 1.01 to the 24th power first, get an answer, and then hit times 8,000. That 8,000 needs to be done very last. Okay. Otherwise, you're going to get some really different answers that are going to be way off base. Okay, so questions about compound interest, if it's compounded a certain number of times per year. The last thing we're going to cover is interest compounded continuously. Okay, first. And so, interest compounded continuously, A equals PE to the RT. The P, R, and T should look familiar. Okay? We looked at those, and those stand for exactly the same thing. Principal, rate as a decimal, and time in years. The E is a little different, though. The E is actually a number, okay, named after Leonard Euler. Euler's name was spelled E-U-L-E-R. Okay, and it's a number that represents the inverse of the natural logarithmic function. And it's basically what we use in this formula. E is the number, it's approximately 2.71828, da-da-da-da-da-da. You have two locations on your calculator you can find it. You can either find it above the ln key, where it says e to the x, or you can see it above the division key, and that's just the number e. I would use the one above the ln key, because everything you're going to be doing is going to be raised to a power. Okay, so let's go ahead and look at an example of a problem. Oops. How much do you have after 5 years if you invest $5,000 at 1.2% compounded continuously? So if you write this down in your notes, you could just put $5,000, 1.2% compounded continuously. Okay. Now this should be a pretty straightforward problem.
What's E?
Okay. So my principal, first of all, is 5,000. I now have E. My rate is 1.2%, but remember I need to answer that as a decimal. So it's 0.012. My time in years is 5. So if you remember from the problem before, we left off the 8,000 to the very end. We're going to do the same thing here. I'm going to calculate the E first. So on your calculator, if you're typing this in, this is what I would type in. And yes, you do need to use parentheses. So notice what I've done, E, and then when you hit that E button above the LN, it's going to give you a little caret. So it's already going to give you the power. Parentheses 0.012 times 5. Okay, did you already get an answer on that? It didn't? Did you use the one above the LN?
Yeah.
Oh, it just went ahead and put it in the power. That's fine. If it went ahead and put it to the power, what you'll want to do is you'll want to do this, 0.012 times 5.
So we don't need parentheses?
No, you could put them, but since it's already in the power, you should be fine. Okay? Then what I want you to do is just take that, when you get that answer, take it times 5,000. So just hit the times button in 5,000, and you should get your answer, which is, okay, you said 18? There you go. Okay, $5,309.18. So, any questions? We've looked at interest that's compounded like certain times of year, and then we looked at it compounded continuously. Tomorrow we'll look at the graphs of the exponential functions. What I need you to do then is page 166, 22 through 30, all. Okay, so page 166, 22 through 30, all.